Good morning, everyone. This is G. Srishant. My roll number is 23211A0582 from CSCB section. Today, we are going to discuss about asymptotic notations. Asymptotic notations are three types. The first one is big O notation, second one is omega notation, third one is theta notation. Now, the first one is the big O notation. The function f of n is big O of g of n. If and only if there exist positive constants c and n naught such that f of n is less than or equals to c into g of n for all n greater than or equals to n naught. Here O big O of g of n denotes an upper bound of the f of n. Here in the graph we can see that the dotted line represents the big O notation, which is the upper bound of the f of n, and here we are representing on the x and y axis. Now the examples of the big O notation are 3n plus 2 equals to of n as 3n plus 2 less than or equals to 4 into n for all n greater than or equals to 2. If we keep the n value 3, now 3 into 3 plus 2, it is 9 plus 2 is 11, which is less than or equals to 4 into 3 12. 11 is less than or equals to 12, so the condition is satisfied. And the remaining examples we can also see the linear and quadratic examples. Second one is omega notation. Here omega the function f of n equals to omega of g of n if and only if there exist positive constants c and n naught such that f of n greater than or equal to c into g of n for all n greater than or equals to n naught. Here omega of g of n denotes a lower bound of the f of n. In the graph we can see that it is the dotted lines are representing the omega notation, which is the lower bound of the f of n, and the omega, these are the omega notations examples, which are the linear and quadratic. The 10n square and 4n plus 2 is the quadratic equation. Now the third one is the theta notation. The function f of n is the theta of g of n if and only if there exist positive constants c1 and c2 and n naught such that c1 into g of n is less than or equals to f of n is less than or equals to c2 into g of n. Means the f of n curve is lying between c1 into g of n and c2 into g of n for all n greater than or equals to n naught. Here it theta of g of n denotes both upper and lower bounds of the f of n. In the graph we can see that the red color and orange color line is representing both upper and lower bounds of the g of n. Here are the examples. 3n plus 2 equals to theta of n. It is the linear, and the quadratic also is represented. And the another notations are the little o notation and little omega. Here f of n equals to little o of g of n. Means for all positive constants c greater than 0, there exists n naught such that f of n lies between 0 and c into g of n for all n greater than or equals to n naught. It describes the upper bound. And the little omega notation, it is represented as omega. It means for all positive constants c greater than 0, there exists n naught such that f of n greater than into c into g of n for all n greater than or equals to n naught. It describes a lower bound. Now thank you. Presentation by Srishant and rule number B section.